Okay, so in this section, we're going to go over calculate the tip. In the last section, we created the XML layout for our tip calculator app. So we're going to be in calculate the tip. That is in the layouts section. So unit 2, layouts, pathway 1, get user input, an app. Okay. Last section, we did create XML layout, and now we're going to calculate the tip. All right, so let's go ahead and take this code lab. All right. In this code lab, you will be writing code for the tip calculator to go with the user interface you created in the previous code lab. Create XML layouts for Android. Prereqs. The code from the Create XML Layouts code lab and how to run an Android app from Android Studio in the emulator or on a device. What we're going to learn the basic structure of Android apps, how to read in values from the user interface into your code and manipulate them, how to use view binding instead of find view by ID to more easily write code that interacts with views, how to work with decimal numbers in Kotlin with the double data type, how to format numbers as currency, how to use string parameters and to dynamically create strings, how to use logcat in Android Studio to find problems in your apps. What you'll build, a tip calculator app with a working calculate button. What you need, a computer with the latest version of Android Studio, starter code for tip time. All right, so we made our user interface, or we did our XML layouts in the last section, so we have that. And we have Android Studio. Okay, so starter app overview. Tip time app from the last code lab has all the user interface needed for tip calculator, but no code to calculate the tip. There's a calculate button, but it doesn't work yet. The cost of service edit text allows the user to enter the cost of service. A list of radio buttons lets the user select the tip percent, and switch allows the user to choose whether the tip should be rounded up or not. The tip amount is displayed in a text view, and finally, a calculate button will tell the app to get the data from the other fields and calculate the tip amount. That's where the code lab picks up. All right, and this is what we created last time. App project structure. An app project in your IDE consists of a number of pieces, including Kotlin code, XML layouts, and other resources like strings and images. Before making changes to the app, it's good to learn your way around. Open the tip time project. If the project window isn't showing, select the project tab on the left side of Android Studio. If it's not already selected, choose the Android view from the dropdown. Okay, project. And they want me to do the Android view. All right. Java folder for Kotlin files or Java files. Main activity class where all of the Kotlin code for the tip calculator logic will go. Res folder for app resources. Activity main.xml layout file for your Android app. Strings contains the string resources for your Android app. Gradle scripts folder. Gradle is the automated build system used by Android Studio. Whenever you change code, add a resource, or make other changes to your app, Gradle figures out what has changed and takes the necessary steps to rebuild your app and installs your app in the emulator or physical device and controls its execution. There are other folders and files involved with building your app, but these are the main ones you will work with for this code lab and for following ones. Note, you can also write Android apps in the Java programming language. View binding. In order to calculate the tip, your code will need to access all of the user interface elements to read the input from the user. You may recall in earlier code labs that your code needs to find a reference to a view, like a button or a text view, before your code can call methods on the views or access its attributes. The Android framework provides methods, find view by ID, that does exactly what you need given the ID of a view, return a reference to it. This approach works, but as you add more views to your app, the user interface quickly becomes complex. Using find view by ID can be somewhat cumbersome. For convenience, Android also provides a feature called view binding. With a little more work up front, view binding makes it easier and much faster to call methods on the views in your user interface. You'll need to enable view binding for your app in Gradle and make some changes. Enabling view binding. Open the app's build.gradle file. In the Android section, add the following lines. So let's just copy that. Build features, view binding equals true. All right, in curly braces. So they said go to Java. Oh. So time, main activity, Gradle, project, module. Which one should I go to? Module tip time. So Gradle scripts, build.gradle, module. Okay. And it said in the Android selection, I believe. In the Android section, add the following lines. All right, so this is in the Android section. Just put it here. Oh, not twice, just once. Okay. All right, and sync it. All right. It synced it. So I guess I'll go ahead and close that. Should be able to use it now. Main activity. Make some room in main activity. Okay. Let's see what it says. Note the message in Gradle that things haven't yet synced that. I did that. After a few minutes, the Gradle sync finished. You can close the build.gradle file if you want. Initialize the binding object. In earlier code labs, you saw the onCreate method in the main activity class. It's one of the first things called when your apps start and main activity is initialized. Instead of calling findViewById for each view in your app, you'll create and initialize a binding object once. So findViewById would have findViewById each time for each different view. View binding would have activity main binding. One binding object has references for all views with an ID. Okay. Open main activity, Kotlin. Replace all of the existing code for a main activity class with this code to set up main activity to use view binding. All right, so class main activity, and then late init var binding activity main binding. Okay. Activity main binding. Okay. All right. Super onCreate Okay, binding equals activity main binding dot inflate layout inflator. Okay, binding equals activity main binding dot inflate layout inflator. Okay. Binding roots. Binding dot root. Okay, cool. So, I mean, I know it said to just copy and paste this and replace it, but whenever possible, I just edit it. So I try to get the hang of doing it myself. So I don't need to look this up again when I need to use it and copy and paste it. Maybe I can just remember it, or at least remember most of it, so I can just get started. All right. This line declares a top-level variable for the class for the binding object. It's defined at this level because it will be used across multiple methods in main activity class. Late init, variable binding, activity main binding. The late init keyword is something new. It's a promise that your code will initialize the variable before using it. If you don't, your app will crash. This line initializes the binding object, which you'll use across the views in the activity main XML layout. Binding equals activity main dot inflate layout inflator. Set the content view of activity. Instead of passing the resource ID of the layout, resource.layout.activity main, this specifies the root of the hierarchy of views in your app, binding.root. Set content view to binding.root. Okay. But it used to say this, and we deleted that and put this right here. You may recall the idea of parent views and child views. The root connects them, or to all of them. Now, when you need a reference to a view, you can get it from the binding object instead of calling find view by ID. The binding object automatically defines references for every view in your app that has an ID. Using view binding is so much more concise that often you won't even need to create a variable to hold the reference for a view. You just use it directly from the binding object. The old way to do it with find view by ID, val my button of type button equals find view by ID resource.id.mybutton. MyButton.text equals a button. So you update MyButton.text. Better way with view binding, val my button of type button equals binding.mybutton. MyButton.text equals a button. Okay. Best way with view binding and no extra variables. So you can just use it right in line. You don't have to create a variable to hold it. Okay. And you can update it right there. Binding.mybutton text. So you're creating the variable when you're making the call. Okay. The name of the binding class is generated by converting the name of the XML file to Pascal case and adding the word binding to the end of it. Similarly, the reference for each view is generated by removing the underscores and converting the name to camel case. For example, in Pascal case, activity main XML becomes activity main binding and can give you access to ID text view as binding.textView. All right. Calculate the tip. Calculating the tip starts with the user tapping the calculate button. This involves checking the user interface to see how much of the how much the service costs, and the percentage tip that the user wants to leave. Using the information, you calculate the total amount of the service charge and display the amount of tip. Add a click listener to the button. The first step is to add a click listener to specify what the calculate button should do when the user taps it. Okay. Binding.calculate button set on click listener calculate tip. Okay. Private function calculate tip. Okay. This is where you will add the code to check the user interface and to calculate tip. So yep, that's what I just did. So I found out that if you click a function without creating it first, it'll put it in red, but then you can autocomplete and you can have Android Studio just create the function for you. So let's pretend I didn't create that yet. So see, like I typed this out and it knows that I'm trying to call a function, but the function hasn't been created. So if you just hover over it and say create function calculate tip, it'll create it for you. So you're just ready to go. All right. Get the cost of service. To calculate tip, the first thing you will need is the cost of service. The text is stored in the edit text, but you need it as a number so you can use it in calculations. You may remember that the int type from the other code labs, but int can only hold integers. To use decimal numbers in your app, use the data type called double instead of int. You can read more about the numeric data types in Kotlin documentation. Kotlin provides a method for converting a string to a double called toDouble. So first, get the text for the cost of service in the calculate tip method. Get the text attribute of the cost of service edit text and assign it to a variable called string in text field. Remember that you can access the user interface element using the binding object and that you can reference the user interface element based on its resource ID name in camel case. So string in text field, val string in text field, and then we're going to probably convert val cost is the string in text field to double. Okay. First, get the text for the cost of service. Val string in text field equals binding dot cost of service dot text. Okay. Bing dot cost text cost of service dot text. Okay. I think that's all it is. Yeah. Notice the dot text on the end. The first part of binding dot cost of service references the user element for the cost of service. Adding dot text on the end says to take the results of the edit text object and get the text property from it. This is known as chaining, and it is a very common pattern in Kotlin. Next, convert the text to a decimal number. Call toDebl on string and text field and store the variable to cost. So val cost equals string and text field toDebl. That doesn't work though. toDebl needs to be called on a string. It turns out that the text attribute of edit text is an editable because it represents text that can be changed. Fortunately, you can convert the editable to a string by calling toString on it. So we should call toString at the end of the other. So toString. Now it works. toDebl. Okay. Now string and text field toDebl will work. At this point, the calculate tip method should look like this. And it does. Get the tip percentage. So far you have the cost of service. Now you need the tip percentage, which the user selected from radio group of radio buttons. In the calculate tip, get the checked radio button ID attribute of the tip options radio group and assign it to a variable called selected ID. So val selected ID equals binding.tipOptions checked radio button ID. So in the calculate tip, get the checked radio button ID attribute of the tip options radio group. Did I call the radio group tip options? What did I call the radio group button? Yeah, radio group tip options. So mine will be val selected ID equals binding dot radio group dot tip options dot checked radio button ID. Okay. Now it's gonna be selected ID equals binding dot radio group tip options dot I think it's checked radio button ID. Checked radio button ID. Okay. All right. Now you know which radio button was selected. One of the resource.id option 20 one of the resource 20%, one is 18%, and one is 15%, but you need a corresponding percentage. You could write a series of if-else statements, but it's much easier to write a when. Add the following lines to get the tip percentage. Val tip percentage equals when selected ID is resource.id.option 20. Okay. Okay, 20, 18, 15. Val tip percentage is when selected ID. All right. Val tip percentage equals when selected ID is resource.id dot radio button 20% tip and 0.2. I think it's 0.2. See, yeah, 0.2, 0.20. Okay. Okay. Resource dot ID dot 18. Okay. 0.18. Resource dot ID dot, or just else. 0 dot 0. Oh wait, 1.5. Okay, makes sense. At this point, the calculate tip method should look like this. And it does. Calculate the tip and round it up. Now that you have the cost of service and the tip percentage, calculating the tip is straightforward. The tip is the cost times the tip percentage. Tip equals cost of service times tip percentage. All right, so tip equals tip percentage times cost. Okay. Note the use of var instead of val. This is because you may need to round up the value if the user selects that option. So the value might change. For a switch element, you can check the isChecked attribute to see if the switch is on. Assigned isChecked attribute of the round up switch to a variable called roundup. Okay, val roundup equals binding dot roundup switch dot isChecked. Okay. 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 The term rounding means adjusting the decimal number up or down to the closest integer value, but in this case, you only want to round up or find the ceiling. You can use the ceiling function to do that. There are several functions with that name, but the one you want is defined in Kotlin.math. You could add an import statement, but in this case, it is simpler just to tell Android Studio what you mean. Ceiling. Okay. If there were several math functions you wanted to use, it would be easier to add an import statement. Add an if statement that assigns the ceiling of the tip to the tip variable if roundup is true. If roundup tip equals kotlin.math.ceiling tip. At this point, the calculate tip message should look like this. All right. Okay. Format the tip. Your app is almost working. You've calculated the tip. Now you just need to format and display it. As you might expect, Kotlin provides the methods for formatting different types of numbers, but the tip amount is a little different. It represents the currency value. Different countries use different currencies and have different rules for formatting the decimal numbers. For example, in US dollars, 1,234.56 would be formatted like that. But in euros, it would be formatted. Fortunately, the Android framework provides methods for formatting numbers as currency, so you don't need to know all the possibilities. The system automatically formats the currency based on the language and other settings that the user has chosen on their phone. Read more about the number formats in the Android developer documentation. In the calculate tip, after your other code, call numberFormat.getCurrency instance. Okay. This gives you a number formatter you can use to format numbers as currency. All right. Okay, number format get currency instance. All right. Using the number formatter, chain the call to the format method with the tip and assign the result to a variable called formatted tip. Val formatted tip equals number format dot get currency instance dot format tip. Number format dot get currency instance dot format tip. Okay. Notice that the number format is drawn in red. This is because Android Studio can't automatically figure out which version of number format you mean. Hover over the pointer over number format and choose the import that appears from val formatted tip. Okay. Hmm. Line did not show it. No, it didn't show. So we'll see. Display the tip. Now it's time to display the tip and the tip amount text view element of your app. You could just assign formatted tip to the text attribute, but it would be nice to label the amount represents, what the amount represents. In the US, with English, you might have it display tip amount 1234, but in other languages, the number might need to appear at the beginning or even in the middle of the string. The Android framework provides a mechanism for this called string parameter. So when someone translating your app can change where the number appears if needed. Open the strings XML, change the tip amount string from tip amount to tip amount colon %s. Okay, so values strings tip amount colon %s. Okay. The %s is where the formatted currency will be inserted. Now set the text of tip result back to the calculated tip. Now set the text of tip result back in the calculated tip method in mainActivity.kt. Call getString resource.string.tipAmount formatted tip and assign that to the text attribute of the tip result text view. Binding tip result dot text equals getString tip amount formatted tip. Binding dot tip result dot text equals getString resource dot string dot tip amount formatted tip. Okay, so we're putting formatted tip. We're putting this into the formatted tip type, I think. Okay. All right. Binding dot text view tip result dot text get string resource dot string dot tip result formatted tip. At this point, the calculate tip method should look something like this. And it does. You're almost there. When developing your app and viewing the preview, it is useful to have a placeholder for that text view. Open Activity Main, find the tip result text view, remove the line with the Android text attribute. Add a line for tools text. Okay, tools text tip amount $10. All right. Because this is just a placeholder, you don't need to extract the string into a resource. It won't appear when you run your app. Note that the tools text appears in the layout editor. Run your app, enter an amount for the cost, select some options, and then press calculate. Congratulations, it works. If you are not getting the correct tip amount, go back to step 1 of the section and ensure you made all the necessary code changes. All right, let's see if it works. All right. I guess I should wait. Installing final version. Okay. Cost of service. Let's say it was 284 and 82 cents. Service was okay. We're not gonna round up. Calculate. Okay. Then let's say service is amazing. Calculate. Okay. Service is good. Calculate. Round up. Calculate. 16. Calculate. Right. All right. Works. Pat myself on the back. All right. Next. Test and debug. You've run the app at various steps to make sure it does what you want, but now it's time for some additional testing. For now, think about how the information moves through your app in the calculate tip method. What could go wrong in each step? For example, what would happen on this line? Val cost equals string in text field to double. If the string in text field didn't represent a number, what would happen if the user didn't enter any text into the field, and the string in text field was empty? Run your app in the emulator, but instead of using run app, use run debug app. Try some different combinations of cost, tip amount, and rounding up the tip or not. Now try deleting all the text of the cost service and click calculate, and the program crashes. Okay. So let's debug. Terminate. All right, so it loaded the app, but in debug mode. All right, let's see. All right, cost of service, we'll say 45.34. All right, calculate. Oh, but I 4,000. So 34. Calculate $10, $9, $7. We'll remove the rounding up. 816, 907. Okay. And then it said just remove the cost of service altogether and try to calculate it. And the app crashes like it said it would. Okay. Debug the crash. The first step of dealing with a bug is to find out what happened. Android Studio keeps a log of what happened in the system, which you can use to find out what's wrong. Press the logcat button at the bottom of Android Studio. Choose View, Tools, Logcat, right? So View, Tools, Logcat. So we could go this way. or we could just go click at the bottom. Okay. All right. All right, so it says in the logcat, fatal exception. All right. And what happened was empty string, right? Fatal exception. All right. Empty string. Right. Read downward until you find the line with the number format exception. Yep. You'll see empty string. All right. The type of exception tells you that something went wrong to do with a number format. The rest tells you that the basis of the problem was an empty string was found when it should have been a string with a value. Continue reading downward until you see some calls to parse double. Below those calls, you'll find a line with calculate tip. Note that it includes your main activity class too. It tells you the line number. See if mine is a newer version of Android Studio, but yeah, it does. It says that too. Main activity calculate tip 27. Main activity line 27 cost. All right. Calculate tip. Hmm. Oh, I was looking for the parse. What did it say? Parse double. Below those calls, there'll be a line with calculate tip. Okay. Parse double. All right. Calculate tip. String in field to double. Okay. Look carefully at that line and you can see exactly where in the code the call was made. Line 22, main activity. If you code type differently, it may be on a different line number. That line converts string to double and assigns the result to the cost variable. Yeah. Okay. Yeah. Look in the Kotlin documentation for a toDouble method that works on a string. The method refers to as string toDouble. The page says exceptions, number format exception. If the if the string is not a valid representation of a number, an exception in the string's way of saying that there is a problem. In this case, the problem is toDouble couldn't convert an empty string into a double, even though the edit text has input type as number decimal. It is still possible to enter some values that toDouble can't handle, like an empty string. Learn about null. Calling toDouble on a string that is empty or a string that doesn't represent a valid decimal number doesn't work. Fortunately, Kotlin also provides a method called toDouble or null, which handles these problems, and it returns a decimal number if it can, or it returns null if there's a problem. Null is a special value, meaning no value. This is different from having a double value of 0 or an empty string with 0 characters. Null means there is no value, no double or no string. Many methods expected a value and may not know how to handle a null and will stop, which means the app crashes. So Kotlin tries to limit the null where the null is used. You'll learn more about this in future lessons. Okay. your app can check for null being returned from to double or null and do things differently in that case so the app doesn't crash. Okay, in the calculate tip, change the line that declares the cost variable to call to double or null instead of calling to double. All right. So line 27 for me, to double or null. Okay. Play. Type mismatch. Inferred type is double, but double was expected. Okay. Okay, after that, add a statement to check if the cost. Okay, I didn't do this part. After that, add a statement to check if the cost is null, and if so, return from the method. Okay, meaning go back, basically. Okay, so cost is equal to null. Okay, and it doesn't crash. So cost, we're setting it, so val cost equals string and text field, all right? And string and field and text field is equal to binding dot edit text cost of service dot text to string. All right, cost is equal to string and text field dot to double or null, and then it said if cost is null, return, and wait, I guess. All right, with no text in the cost of service field, tap calculate. This time your app doesn't crash. Good job, you found and fixed a bug. Handle another case. Not all bugs will cause your app to crash. Sometimes the results might be potentially confusing to the user. Here's another case to consider. What will happen if the user enters a valid amount for the cost, taps calculate to the calculate tip, and deletes the cost, and then taps calculate again? The first time the tip will be calculated and displayed as expected. The second time, the calculate tip method will return early because you just added the check. But the app will still show the previous tip amount. This might be confusing to a user. Add some code to clear the tip amount if there's a problem. Okay? So binding.tipResult.text equals. All right. So add that in the check before the return. Okay, so let's rerun it. Okay, so doesn't crash when there's nothing there. 453, so 7. Okay, we're gonna say this 81, 68, and then let's see if clearing this and doing it again removes that, and it does. All right, cool, because we put removing that in our check. This will clear the tip amount before returning from calculate tip. Run your app again, try the above case. The first tip value should go away when you calculate the second time. All right, next. Your calculator works now, but you can make code a little bit better and make it easier to work with in the future by adopting good coding practices. At the beginning of the calculate tip method, you might see that it is underlined with a wavy gray line. No, ours is not. Oh, because it made it private when I auto created it. Could be private. Okay, so I already hit it. That's why. So recall from earlier code labs that private means that the method is a variable only visible to the code within that class. In this class, main activity class, there's no reason for the code outside main activity to call calculate tip, so you can safely make it private. The gray line is very subtle and easy to overlook. You could look through the whole file for more gray lines, but there is a simpler way to make sure that you find all suggestions. Within main activity, still open, choose Analyze, Inspect Code in the menus. Okay. Okay. Well, Analyze, Inspect Code in the menus. Okay. Include test sources. Okay. Choose the option that starts with file and press OK. This will limit the inspection to just main activity. A window with inspection results appears at the bottom. Click on the gray triangles next to the Kotlin, next to style issues until you see two messages. The first says class member can have private visibility. Okay. Click on the gray triangles until you see a message. Property binding could be private, and click on the message. Android Studio displays some of the code in the main activity and highlights the binding variable. Okay. Press Make Binding Private button. If you are looking at a binding in your code, you'll see that Android Studio has added a keyword private before the declaration. Click on the gray triangles in the results until you see a message variable declaration could be inlined. Okay. Selected ID. If you look at the code, selected ID is only used twice. First, in the highlighted line where it is assigned the value of tip options checked radio button, and the next in the when. All right. Press inline variable. Android Studio replaces selected ID in the when expression with the value that was assigned in line before and removes the previous line completely because it's no longer needed. So this is what it looks like now. Selected equals this. And instead, it probably just takes away selected ID and puts it right into the when. I'm guessing. Guessing it puts binding dot tip options dot checked radio button ID right in here. So let's take a look at that. Yep. And it took that variable away because it says we don't need it. We could just do this because this is only used one spot, and the only other place that was talked about was right before it. Okay. If you look at the code, you'll see that the selected ID is only used twice. Okay. All right, is no longer needed. Yep, that's pretty cool. Your code has one less line and one less variable. Removing unnecessary variables. Android Studio doesn't have any more results from inspections. However, if you look at your code closely, you'll see a similar pattern to what you just changed with the round up variable. Is assigned on one line, used on the next, and not used anywhere else. Replace round up in the next line with the expression you just copied and get rid of the variable. Okay. Round up. So basically just take this. All right. Cut. Paste. And get rid of round up. All right. It should work just fine still. Delete the line with round up because it isn't needed anymore. You just did the same thing that Android Studio helped you to do in the selected variable. Again, your code has one less line and one less variable. These changes are small, but they help you make your code more concise and more readable. Optional, eliminate repetitive code. Once your app is running correctly, you can look for other opportunities to clean up your code and make it more concise. For example, when you don't enter a value in cost of service, the app updates tip results to be empty string. When there is a value, you use number format to format it. The functionality can be applied elsewhere in the app. For example, if you display to display a tip of 0.0 instead of an empty string. To reduce duplication of very similar code, you can extract these two lines of code to their own function. This helper function can take input as a tip amount as a double, format it, updates it, the tip result text view on the screen, identify the duplicated code in the main activity. These lines could be used multiple times in calculate tip function, once for the 0, 0 case and once for the general case. Okay. All right, I didn't really understand that, so I'm just gonna auto format the code and then I'm gonna read that again. All right, let me read this again. Once your app is running correctly, you can look for more opportunities to clean up the code and make it more concise. For example, when you don't enter a value in the cost of service, the app updates tip result to be an empty string. when there is a value, you use number format to format it. This functionality can be applied elsewhere in the app. For example, to display a tip of 0.0 instead of using an empty string. To reduce the duplication of very similar code, you can extract these two lines of code to their own function. This helper function can take as input a tip amount as a double, formats it, and updates the tip result text view on the screen. Identify the duplicated code in main KT. Val formatted tip equals number format dot get currency instance dot format 00. Okay. Binding tip result dot text equals get string resource string tip amount formatted tip. Okay. Move the duplicated code to its own function. Private function display tip double. Private function display tip double. Okay. Now I gotta add line cost is equal to 0. Display tip 0. Okay. I think line, nope, nope, line, or cost is equal to 0. Okay. Yeah, so let's see if it works the same way. Hmm. Okay. Even though the app is now functioning, it's not ready for production yet. You need to do more testing, and you need to add some visual polish following material design guidelines. You'll also learn to change the app theme and the app icon in the following code labs. All right, solution code. The solution code for this code lab is below. All right, cool. Cool. Summary. View binding lets you more easily write code that interacts with the user face elements in your app. The double data type in Kotlin can store the decimal number. Use the checked radio button ID attribute of a radio group to find which button is checked. Use the number format.getCurrency instance to get a formatter to use for formatting numbers as currency. You can use string parameters like %s to create dynamic strings that can be easily translated into other languages. Testing is important. You can use Logcat in Android Studios to troubleshoot problems like app crashes. A stack trace shows a list of methods that were created. This can be a useful thing. This can be useful if code generates an exception. Exceptions indicate a problem that the code didn't expect. Null means no value. Not all code can handle null values. I've had a lot of trouble with this in a lot of things I've been trying to do, so I need to learn more about null values and how you can use them and when you should use them and when you should be careful not to. Use the analyze inspect code for suggestions to improve your code. Cool. More code labs. Great job on getting the tip calculator to work. Notice that there are still more ways to improve the user interface to make the app more polished. If you're interested, check out the code labs and learn more about how to change the app theme, app icon, as well as how to follow best practices for material design guidelines for tip time. All right. Learn more. Cool. Practice on your own. With the unit converter app for cooking in the previous practice, add the code logic for calculations to the converters, like converts units to millimeters or from fluid ounces. So I didn't do that practice yet. I'm going to have to make a separate video for the practice. All right, guys. That's it for this video. That was, calculating the actual tip in the user interface for the app tip time. Cool. So I'll see you guys in the next video. Done. And the next video will be the quiz. Okay.